Hello everyone, my name is Runbang. I'm from China. Today, my topic is CAFM, which is a precise classification for Android family malware. My presentation will include these 5 parts. First, some background information about this research. Second, the feature extraction and the problem statement. Third, the main work we have done. Fourth, the experiment we have done. And the last, some conclusion we have got. Well, let's move on the first part of this topic. The motivation of this work like this. Recent developments in the diversity of family malware have highlighted the importance for Android mobile phones security. Users are at increased risk, which puts greater demands on antivirus organizations and the security researchers. As shown in the picture, it indicates that the adware and the risk tools types require more attention than warm from antivirus organizations and security researchers. Therefore, it is necessary to propose an effective classification for family malware. However, given innumerable families and masses of software candidate features, family classification faces 2 technical challenges. Challenge 1. Difficulty in obtaining features that contain enough family representative peculiarity information. Family malware is innumerable and various in its features. It is necessary to select the feature subset that can represent innumerable families' behavior characteristics. Challenge 2. Difficulty in constructing a classification model that adequately learns the peculiarities of each family. The diversity of families leads to different calling relationships to implement malicious behavior. So, aiming at these challenges, an effective family malware classification method is proposed in this paper. We have 3 major contributions. 1. To obtain representative features. The feature expressions in different families are analyzed, and the feature in diverse families is minded. 2. An effective deep network classification model for automatic learning of internal patterns is constructed. The effective automatic extraction of the input features is realized. 3. Experimental results show that the proposed CAFM performs well on a real-world dataset with an accuracy of 95.45%, which is at least 5.46% higher than comparative classifiers. Now, let's move to the feature extraction and the problem of our and the problem statement of our research. The feature exploration can be split into 3 parts. First, decompile the APK file to get the smelly file. 2. Extract the Delvic OP codes and the API from the smelly file. 3. Obtain OP code sequence according to the Android OP code constant list and the API list. Then we give a definition to the problem. The family malware classification is to classify the unknown attribute samples into the class of the family. That is, to give the class label of the family of the detected samples, and we decompose it, the definition, into two parts: feature depiction and feature memorizing and sample prediction. Now let's move to the model of our research. As shown in Figure 3, our framework includes two parts, as described above. Feature depiction. This module is to optimally represent the extracted OP code sequences and API features. It allows the OP code and API information to be included as much as possible, while forming a corresponding data format for the input of the classification model. Feature memorizing and sample prediction. This module is utilized to train features and predict unknown samples. Training is the stage of learning and memorizing features. The model obtains the high-level feature representation of features. The compilation of training represents a formation of the classification model, which can predict the label of unknown samples. Feature prediction is to select the pivotal elements of the extracted features and represent them in a format that can be recognized by the classification model. API features are selected based on their frequency of occurrence in the dataset, from high to low. First, acquire original features. Second, coding. APIs have a fixed number in the API dictionary in descending order of frequency. And the last, representation. The extracted OP code sequence and the location corresponding to the API are used for data form representation. The range of each OP code is 0 to 256, which is a decimal number. The value of the API is 0 or 1, and the position of the API is set to 1 when this call occurs for the sample. Otherwise, it is 0. Feature memorizing is the learning process of the classification model. For feature knowledge, and the sample prediction is the label prediction using the learned classification model. We use 1D CNN with 2 channels. First, improve the ability to the network to obtain information. 2 channels can input different features to obtain feature information from different angles in the family, providing more information. Second, obtain the original feature information to a great extent. The opcode sequence itself contains the sequence of the called opcodes, which includes context information and relative location characteristics. This is closer to the data format of a 1D signal. All parameters have been obtained in the previous stage. This stage only needs to input the vectorized data from the input layer to realize predictions. Now let's move to the experiment of our research. As shown in figure 4 and figure 5, when the length of the opcode sequence is 700, the classification of fact is better, and only a few samples are misclassified in the phase of the family with the highest similarity in the 8 variants. The F1 micro and the kappa reach 0.9773 and 0.9725 respectively, which shows a favorable family classification effect. As shown in the pictures above, it can be seen that the same family represents a certain regularity in the distribution of opcode numbers. These all demonstrate similarities in the length of opcode sequences within the same family or within the same variety, reflecting similar more evolent behavior, and that might be possible. In short, CAFM has shown relatively good results in various indicators. The comprehensive classification indicators F1 micro, F1 macro, and kappa have all achieved more than 0.9317, which is an ideal multi-classification effect. Now let's move to the conclusion of our research. This paper proposes an effective classification for family malware, though in-depth analysis of features, feature subsets are obtained, which can represent family diversity. A 1D CNN with 2 channels is designed, which can not only utilize the original feature data format to a greater extent, but also preserve the information of the source features. The design of 2 channels fully learns the internal abstract pattern of fusion features and provides a more accurate model for family classification. That's all my presentation. Thank you for listening.